Welcome to Excellential School of Chemistry, and we are here presenting qualitative analysis of this year's WASSCE examination in chemistry. Before we proceed, I want to urge you to please subscribe to this channel and like the video so as to help us serve you better and so that you can see our subsequent videos. And I also want to urge you, when you enter the examination hall, ensure you read the questions. The questions must not be as presented here. These questions I'm giving you here are just guides. Yes, trying to guide you on what to possibly do. And having noted that, we have the question on the screen. You are provided with samples C and D. Carry out the following tests on C and D. Record the observations and conclusions appropriately. AI, put the whole of C in a boiling tube and add about 10 cm³ of distilled water to it. Stir thoroughly and test with litmus paper. Divide the resulting mixture into two. So that is preliminary, and for want of time, I wouldn't be carrying out these details. I will just be showing you the results. I have some of the results here with me. I've already carried them out, so you shall see it. So this, now we have C plus water plus litmus paper. C dissolves in water, and the inference, that is the conclusion, shows that C is soluble in water. And with litmus paper, there is no effect on litmus paper. Shows that C is neutral. C solution is neutral. So let's say C solution is neutral. Yes, and then the next one is II. You are asked to divide the resulting mixture into two. So the first portion, add 2 cm³ of K2Cl2O7, that is potassium dichromate, followed by 1 cm³ of dilute H2SO4, then boil. And when you boil it, you see this is potassium dichromate, right? Can you see it? It's orange in color. And this is, when you add the potassium dichromate acidified and you boil it, it will turn to green, okay? So the color changes from orange to green. Yes, it will give you a green solution. Of course, that shows that the sample is a reducing agent. It's only the reducing agents that do that. And if you were told initially that C is a carbohydrate or is sugar, you then have to also infer here that C is a reducing sugar. But if you have not been informed that it's a carbohydrate or a sugar, just infer here that C is a reducing agent. Okay? And alternatively, we have here, it says, to the first portion, add 2 cm³ of AgNO3, followed by 1 cm³ of aqueous ammonia, then boil. Okay, when you add them and boil, you're going to, this is it here. If you are here, you're going to see silvery coloration, a kind of mirrory coloration on the walls. If you have not, but if you shake it, it will disrupt it to a large extent. But here is mirrory, that is silver mirror in the inner walls of the test tube. That shows that C contains alkanals, okay, alkanal group or aldehyde, and C is a reducing agent, is a reducing sugar. Now, if they include sodium hydroxide in the equation, it will still give you silver mirror, as this one, as you can see here, and that is it on the II. And now for the III, the question says, to the second portion, add failing solution A and B, then boil. When you add failing solution A and B to the aqueous solution, here is it. You see blue, it will turn blue. If you leave it to stand for some time, it will start to turn a bit of yellow or so, gradually, but here it's still bluish to a large extent. And when you now boil it, you see it. You have a briquette precipitate. We don't forget the briquette precipitate, or you say that it's briquette precipitate, or it's more of orange anyway. But briquette precipitate is what you report. And of course, this one with silver nitrate, if it doesn't form silver mirror, to give you black precipitates. Okay. Yes, and the last one, put D in a boiling tube, then heat it thoroughly, strongly. When you heat it strongly, I did it here, but because I wouldn't want to take some time, this has been here for a while. been here for a while, so when it cools, it turns back to white. So here is it turning back to white. And then, but if you heat it now, you have to take like 3 to 5 minutes or even more, okay, to change yellow. You leave it to cool, it will change back to white. That is the simple observations here, and that is it. So that is it on D. It means that D is zinc oxide. D is zinc oxide. Zinc oxide is the only substance that has that characteristics. Heating it, it turns yellow. Cooling it, it turns back to white. Okay, so that is it on D. D is zinc oxide. It turns yellow when heated and turns back white on cooling. And of course, some other possible taste on D, although quite unlikely. If you're asked to taste it with if you add HCl to it, it will dissolve. Okay, yes. And even if you also add sodium hydroxide, it will still dissolve. Yes. And then when you put it in water and add sodium hydroxide in drops, it will give you white gelatinous precipitate, which will dissolve in excess sodium hydroxide. That will make you to suspect both zinc ion and aluminum ion. But when you now have the sample in water, you put aqueous ammonia in drops to give you white gelatinous precipitate. You add it in excess to give you it will dissolve. Okay, the precipitate will dissolve. That will show you that D contains zinc ion. Thank you very much. Thank you once again, and don't forget please to subscribe to this channel and like the video, and watch out for our subsequent videos. And also, we already have the video on volumetric analysis. If you have not seen it, please do check out for it. Thank you again. We wish you the best in your examination. Ensure you read your questions very well. Ensure you relax your mind. Do not mutilate any of your values. Rule your tables very well and write using pen. Best wishes.